Okay, this is the part 2 of the review video 1.7 and 1.7 to 1.11. It says that determine if the following rational functions have a horizontal asymptote, slant asymptote, or neither. So they're not really asking us to find, but just to figure out whether it has HA or SA or neither. So we learned this already, that horizontal asymptote is possible when the degree of a numerator is less than equal to the degree of denominator. If this happens, then yes, there is a horizontal asymptote. But if for slant asymptote, the degree of the numerator should be exactly one more than the degree of denominator. And if neither of this happens, then it will be the neither case. So for example, over here, the degree of numerator is 2, the degree of denominator is 3. The degree of numerator is less than or equal to, obviously it is less than, right? It is less than denominator, so this one has horizontal asymptote. Over here, the degree of numerator and denominator both are equal, so once again it falls in the same category, so it has horizontal asymptote. But here the degree of numerator is 3, the degree of denominator is 2, and the degree of numerator is exactly 1 more than the degree of denominator, so it is a slant asymptote over here, right? Okay, let's talk about these. So here the degree is 4, here the degree is 2. Degree of numerator is greater than denominator, but it's not greater than by 1 only. It is greater by it is greater. The difference is more than 1, right? It's 2. So in this case, it is neither horizontal asymptote nor the slant asymptote. So I'm gonna say this is a neither case. Over here, the degree will be x and x, so it will be x squared. I know it will be 6x squared, but I'm not really interested in the number. I'm just interested in her degree. And x will also give me x squared. So yes, this has a horizontal asymptote because the degree of numerator and denominator are both equal. And over here, this will give x cubed, this will give x squared, this will give x squared, this will give x to the 5. So the numerator will give me x to the 5 in total, and the denominator will give me x to the 7 in total. Since the degree of denominator is greater than the numerator, so this will give horizontal asymptote. Over here, this will give x to the 4. This is x, and this will give x squared, so this will give x cubed in total. And the degree of numerator is 1 more than denominator, so this will give slant asymptote. Over here, x square will be x to the 4, and x squared times x will become x cubed. Here as well, the degree of numerator is 1 more than the denominator, so this is a slant asymptote case as well. Here the degree of numerator is 0, degree of denominator is 1, so degree of numerator is less than denominator, so this is horizontal asymptote case. We need to solve the following inequalities now and write our answer in interval notation. So if we remember, we had these questions, I think similar questions in part A of this video as well. The idea is to make a number line. First, make sure that the leading terms everywhere is positive, so it is positive here. Then we plot the roots, so roots are -3 and 2. And then we take any point greater than 2 that we like, probably 100, and we see that what is the sign of this expression when we put x as 100. So 100 minus 2 is positive, 100 plus 3 is positive, so this will give me positive. And then we learned a rule that if all the powers are odd, then, as in the powers of all the factors are odd, then you just toggle the sign. So plus, minus, plus. They need less than equal to 0, which is obviously this one. But be careful about the equal to 0, because usually just with the flow we include -3 and 2. But this is not a polynomial, this is a rational function, and -3 is definitely not allowed because it is making the denominator 0, and I cannot really allow that. So it's -3 parentheses and 2 bracket. Likewise, the next one is I'm going to make a number line here. The roots are I think -5, -1, and 3. I don't really care about this one because this is whole square, so it doesn't matter what x I put, that's going to always return a positive number. So I'm just going to focus on the denominator two terms to get the sign. Okay, any number greater than 3 that we like, maybe 100. So 100 minus 3 positive, 100 plus 3 positive, so this is positive. Between -1 and 3, probably 0. So 0 minus 3 negative, 0 plus 5 positive. So negative positive is negative. Between -1 and -5, maybe -4. So this will be negative and this will be positive. So again negative. And less than -5, maybe -100. So both will be negative and double negative is positive. They need greater than 0, right? They need greater than 0, so that's going to be, this was -5, so it's going to be -infinity to -5 union 3 to infinity. That's where it is positive. Okay, over here I don't like this negative leading coefficient, so first I'm gonna multiply with -1 both the sides so that this becomes positive and the sign flips. Okay, I'm gonna make a number line here. In the number line, I'm gonna have -2 here. I'm gonna have 0 here. I'm gonna have 7 here. So anything greater than 7 that you like, and remember this is irrelevant because that's always gonna return a positive number. So greater than 7, maybe 100. 100 minus 7 positive, 100 positive, so double positive will be positive. Any number between 0 and 7, probably 2. So 2 is positive, 2 minus 7 negative, positive and negative is negative. Between -2 and 0, maybe -1. So -1 will be negative here, -1 will also give negative, so double negative is positive. And any number less than -2, probably -100. So -100 negative, this is negative, double negative is again positive. I need greater than equal to 0, but remember, be careful about these points because -2 is definitely not allowed because it is making denominator 0. So the answer will be -infinity to -2 union -2 to 0 union 7 to infinity. That's our final answer. Right, let's do question 13 on the next page. First, we need to factorize this. So I think the numerator is easy to factorize. It's just x plus 7 and x 7 4s are 20, x minus 4. Yeah, x plus 7, x minus 4. And this is x taken out. I'm left with x minus 9 is less than 0. All the leading terms are positive, leading coefficients are positive. So make a number line. Here we are, and I think this is lucky because everything is odd, so I can just toggle the sign, right? So this is -7, 0, and 4, and 9. So start with the most right, greater than 9. If you put 100 everywhere, it should be positive. So plus, minus, plus, minus, plus, and I need negative. So x is an element of -7 to 0, union 4 to 9. That's going to be our answer. Okay, we need to figure out where it has a hole and where it is a VA. All right, so let's do that. This is hole, this is VA. Okay, it's all about paying attention to the degrees of the factors. All right, for the first one, we have, let's see what is common. I think x plus 4 is common and same degree, so definitely that is a whole. So x is equal to -4. And is there a VA? Yes, definitely there is a VA. It is x equal to 1. There's not even any factor on the top. So yeah, unarguably, this is the VA. All right, that's about it. Here, x minus 3 is a factor and the degree of bottom is more. So definitely it is a VA. And x minus 8 is also a VA because there is nothing on the top. So yeah, that will also give a VA and there is no hole over here. Here, although x minus 7 is common, but the degree of numerator is more. So that's going to give a whole. And here, x is only in the denominator. So that's going to give a VA. So x equal to 0 is the equation of vertical asymptote. Okay, over here as well, I think we need to factorize this. So this can be very easily factored as x minus 6, x plus 4, 2, sorry, x plus 2. And this is, I think, just x minus 6, x minus 6. Yeah. What is common here? Oh, it will rather be x minus 6 whole square, and now it makes more sense because that will be a VA as the degree of denominator is more. So x equal to 6 is VA, and there are no holes. Over here, if we factorize, that's going to look like x minus 3, x plus 3 on the top, and this will be x taken out. I'm left with x squared plus x minus 6. So this will be x minus 3, x plus 3. And over here, I have x times x plus 3 and x minus 2. Equal to negative 3 as a whole, right? Because that's common on the top and bottom. So x equal to negative 3 is a x equal to negative 3 is a whole in this case because it is common on the top and bottom. And this over here is only at the bottom, so these will return VA. So x equal to 0 and x equal to 2 are VA. The last one, well, luckily factored for us. So here this is common, but the degree of numerator is more, so that's going to return a whole. And here the degree of the denominator is more, so that's going to return a VA. V5 is a VA. All right. Write the equation of horizontal or slant asymptotes. So horizontal asymptotes are the easiest because it's just the ratio of the coefficients, right? So here the degree of top and bottom is same. So the ratio of the leading coefficient is 1 over 3. So y equal to 1 over 3 HA. Here the degree of the denominator is more perfect. So that's going to be just y equal to 0, again HA. But in this case, we need to do a long division because we need to figure out what the slant asymptote is. So you're going to do that. X plus 2 to be divided, x plus 2 divides 4x squared minus 3x plus 5. So here we have 4x and I'm left with 4x squared plus 8x. I'm going to subtract this. This is cancelled, and negative 3x minus 8x is negative 11x, and the 5 is dropped down. Then negative 11x divided by x is negative 11. And I don't really care what happens here because the top is the VA. I think this is what we discussed in part A of this video as well, right? So this is, sorry, not VA. I mistakenly said VA, SA. This is the slant asymptote quotient. Right. Right, this one is also a slant asymptote case. So I'm going to say that x squared plus x plus 3 divides x cubed minus 2x squared plus 4x minus 1. So x cubed divided by x squared is just x. So this will be x cubed plus x squared plus 3x minus minus minus. This is gone. This will become negative 3x squared. 4 minus 3 is just 1. So x, and negative 1 is dropped down. Negative 3x squared divided by x squared is just negative 3. And again, I don't really care what happens here. The answer is y equal to x minus 3. That is the slant asymptote. Over here, the degree is, well, x cubed, and this is also x cubed. Well, this is HA. So the leading term on the top is 2x cubed, and here it's x cubed. So horizontal asymptote is just y equal to 2. Over here, the degree is on the top is x to the 4, and the degree at the bottom is x to the 5. Lucky, denominator is greater, so y equal to 0 is the horizontal asymptote in this case. In this question, we are given a graph of the rational function, and we need to figure out which of the following could be an expression for f. I suppose that the whole is the easiest to figure out because at x equal to 5 we have a whole. It means that the x minus 5 expression should definitely come in top and bottom both. Here x minus 5 is only in the denominator. That doesn't work, right? Because that's going to give a VA. That doesn't work for us. This is definitely a strong contender because it's on the top and bottom. This won't work because this has x plus 5, but I need x minus 5 so that x equal to 5 gives a whole. And this will not work as well because x equal to 5 is only at the top, which will actually give me 0 rather than a whole. So that was actually pretty easy based on the options. That's just option B. We have to figure out which rational function has a whole at x equal to 3 and a vertical asymptote at x equal to -2. All right. Likewise, if it has a whole, then x minus 3 should appear at the top and bottom both. So yes, option A is a strong contender. Option A passes. Option B cannot be it because x minus 3 is only at the bottom. That makes it a VA. Nope. Option C, yes, definitely. X minus 3 is at the top and bottom. And option D, nope, because x minus 3 is only at the top. So that's going to make it as 0. The next is VA x plus 2. So x plus 2 should be at the bottom, ideally only at the bottom. And here, unfortunately, x plus 2 is at the top. That doesn't work because that's going to give us 0. So this is not a, well, this will work because x plus 2 is only at the bottom. So it's going to give me a vertical asymptote. Which of the following is correct about this function? So as we can, it's about VA and horizontal asymptote, of course. We can clearly see that the VA is x plus 1 because x plus 1, although both at the top and bottom, but the degree of the bottom is more. So x plus 1 equal to 0, which is x equal to -1 is a VA. So it has to be either B or D. Then they're talking about horizontal asymptote. So let's find out the degree of the top. That's going to be 3, as an x cube will come from here and x square is going to come from here. So that is x raised to 5. And x square is here, x raised to 4 is here, and this is x raised to 6. And clearly the degree of the denominator is greater than the numerator. So the answer is just y equal to 0. That's the horizontal asymptote, which makes option D as the correct choice. This is a good question, guys. We have to figure out that which of the following about h is correct. So they are talking about horizontal asymptote. Now, this may seem like a degree of 5, but actually it's not. We are going to have to use Pascal's triangle in this question. To figure out the expansion of x minus 2 raised to 5. Honestly, I don't even need the entire expansion, but just for the sake of explaining, I'm gonna still open the entire thing. So I'm gonna make the Pascal's triangle here: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 2, 3, 4, and I think I'm gonna write another one. So 1, 1, 5, 10, 10, 5, and this is what I'm interested in. Now, when I open this up, I'm gonna have these as the coefficients, and the greatest power will obviously be x raised to 5 with a coefficient of 1. Likewise, 5 times x raised to 4. I'm just gonna write the x terms first: x raised to 4, then 10 times x cube, then 10 times x square, then 5x, and then 1. And then we are gonna write since it is x minus 2, so it's gonna toggle the sign. So plus, minus, plus, minus, plus. So this is plus, minus, then plus, and then minus, and then plus, and then the last term will be minus. Okay. And then we are going to write the powers of 2 starting from 2 raised to 0. So this is 2 raised to 0, which is just 1. And then 2 raised to 1, then 2 raised to 2, then 2 raised to 3, 2 raised to 4, and then 2 raised to 5. So this x minus 2 raised to 5 will look like this. And remember, there is a minus x raised to 5 as well. So it's minus x to the 5 and divided by 3x to the 4. Now these two are gone. And now you understand that why I said I don't really need the other terms, because I'm only interested in the leading term. And the leading term on the top is only this one, right? So it's negative 10 x raised to 4 at the top and 3x raised to 4 at the bottom. And the horizontal asymptote is just going to be, since the degree is same, The answer is the ratio of the leading coefficient, which is negative 10/3, which makes option D as the correct choice. Right, which of the following values of x are zeros of the graph? So first we need to factorize this. I think this is easy to factor. It's going to look like x plus 3 times x minus 2 over x taken as a common factor. I'm left with x squared minus 5x plus 6. So that's going to look like x plus 3, x minus 2 over x times x minus 2, x minus 3. Now, zeros means only top should be 0, but unfortunately here x minus 2 is making the denominator 0 as well, so that cannot be my answer. The only option left is x plus 3, because that will only make the numerator 0, which is going to give me a 0 of this function, which is option B.